Starting off chapter 6, we are going to be talking about properties of square roots. So our learning goal for today is I will simplify and evaluate square roots. And I will simplify radical expressions. So that's what we're shooting for today. Starting off, we just want to remember what a square root is. So remember, if I square a number, something like 3 squared, that means 3 times 3, and that gives me 9. The square root is the inverse operation, which just looks like this. That's called a radical, that symbol right there, that means square root. So if 3 squared equals 9, then the square root of 9 equals 3. It's just the inverse of squaring. Now there are a couple of properties that go along with square roots that make it a little easier to simplify them and just to work with them a little bit. So for example, I'm going to show you with symbols first, and then I'll show you with numbers. If we have the square root of x times y, or xy, that's a square root symbol, I can actually break this into 2 separate square roots, the square root of x times the square root of y. So what that means is if I had something like the square root of 4 times 3, I could break this into the square root of 4 times the square root of 3. The square root of 4 is 2 because 2 times 2 is 4. So I could write that as 2 times the square root of 3. The square root of 3 is not a rational number. It doesn't work out to be anything that looks nice. It's just a number with a decimal that goes on forever without ever repeating, so it's irrational. So this is how I would write the square root of 4 times 3. Now think back, square root of 4 times 3 is actually the square root of 12. So this is a way of simplifying the square root of 12, and we'll get to that in a minute. This works the same way when we're talking about the quotient or when we're dividing. So if I have the square root of x divided by y, I can break this into the square root of x divided by the square root of y. And, I can do the same thing then. If it's the square root of 3/4, that's the same as the square root of 3 over the square root of 4, or the square root of 3 over 2, because 4 is a square number. It has a nice square root. So these are just ways that we're going to simplify. So for our first example, we're starting off with just a couple of numbers. Example 1a, if I had the square root of 28, I'm going to think about the factor pairs of 28 and try and figure out if there are any square numbers inside of 28. So like 28, if I listed the factor pairs, it's 1 and 28, 2 and 14, 4 and 7. 4 is a square number, so that's what I'm going to want to use to simplify this. I'm going to think about the square root of 28 as the square root of 4 times 7. Then I can break this apart using my rule from above into the square root of 4 times the square root of 7, which will simplify to 2 times the square root of 7. So another way of writing the square root of 28 is 2 times the square root of 7. And right now this might not look any better. However, it actually is going to help us later on when we have things that we need to do with square roots. We can do the same thing with the quotient rule like we did before. So for example, 1b, if I wanted to take the square root of 11 over 100, I could simplify that to the square root of 11 over the square root of 100. No whole number squared gives me 11, so I'm going to leave that as the square root of 11. But the square root of 100 is 10, because 10 times 10 is 100. So the square root of 11/100ths could also be written as the square root of 11 over 10. Now for my next example, I have a square root with variables right now, and I'm going to evaluate this. This square root of b squared minus 4ac is something that's going to come up again when we talk about quadratics. For now, it just looks like a totally random thing, but you're actually going to be using this a ton later on this year. So I want to evaluate this square root when a equals 3, b equals 4, and c equals -2. So my first step is just going to be to make those substitutions. And notice that the square root sign goes over everything. So I need to figure out what's under that square root first, do all of the math under it, and then take the square root at the very end. So b squared is 4 squared minus 4 times a times c. And like I said, I'm going to do all of this math first. So 4 squared is 16 minus 4 times 3 is 12 times -2 is going to be -24, or another way of writing that would be 16 plus 24, which means that's going to be the square root of, I'm going to make 10, 20, 30, 40. But this is actually not simplified because there is a square number inside of 40. So again, if I think about the factors of 40, I know that 4 goes into 40, and 4 is a square number. So I want to think about that as the square root of 4 times 10, which is the square root of 4 times the square root of 10, or another way of writing that would be 2 root 10. That might look ugly, it might not look very helpful, but trust me, it will be someday. So my solution here, or my answer for when I evaluate this for these given variable values, is 2 times the square root of 10. If you stopped here, that is not simplifying all the way. You don't want any square number factors under that square root sign. It can be helpful to have a list of the numbers like 1 through 15 or 1 through 20 and the squares of each of those numbers, so then you know what you're looking for. The more that you do of these, though, the more you'll recognize and the better you'll get at just pulling out square number factors. You know, if 25 is a factor, if 36 is a factor, if 4 is a factor, if 9 is a factor, 16, all of those are things that you can pull out. Something else we can do with radicals or with square roots is we can take fractions or problems that involve the square root and we can simplify them. So for example, I want to simplify 18 plus the square root of 72 all over 6. And my first step here is going to be to look at that square root and see if I can simplify it any further, just that square root part. So if I think about the square root of 72, or my factors of 72, 1 and 72, 2 and 36. There are probably a whole bunch more, but when I see that 36 right there, 36 is a square number. 36 is 6 squared. So instead of writing this as a square root of 72, I want to think of it as the square root of 36 times 2, which is the square root of 36 times the square root of 2, or 6 root 2. So what I'm going to do is I'm going to take this and I'm going to replace the square root of 72 with 6 times the square root of 2. Those are totally equivalent, it's just different ways of writing it. So this will be 18 plus 6 times the square root of 2, all divided by 6. And then when I look, I can see that 18 is divisible by 6, and 6 times the square root of 2 is divisible by 6. So this could be 18 over 6 plus 6 root 2 over 6. 18 divided by 6 is 3. This is 6 times the square root of 2, so I can factor out that 6, and I'm left with just the square root of 2. So what I did is, because I simplified that square root of 72, I was actually able to get rid of the fraction altogether. This whole fraction right here is the same as 3 plus the square root of 2, which in my opinion is a much nicer way of writing that. Now, as you go through these problems where you're simplifying, and there is a real-world example where you substitute some numbers and go through, you can just look at that example in your book. But something that I just want to point out to you is that if you had the square root of x plus y all under the square root, that is not the same as the square root of x plus the square root of y. You cannot break it up into those like you can when it's multiplication. Same thing goes for subtraction. You cannot break it into two separate square roots. So you just want to be really careful with that. You can only use the product rule when it's a product, when you're multiplying. So just keep that in mind as you go. Now, these are going to be a little tough at first because you're just not going to be very good at recognizing square roots, or you're not going to be good at recognizing square factors, but I promise the more that you do, the better you're going to get at these. So just keep practicing, keep doing them, do all the homework problems, maybe do a couple extra if you're struggling, and really the best way to get better at this is to just practice, practice, practice. So good luck.